We know that the square root of 9 is 3 because 3 times 3, when I multiply 3 times itself 2 times, I get 9. What if I want to do something like, I want to ask a slightly different question. I don't care about what I have to multiply times itself 2 times to get 27. I want to know, what do I have to multiply times itself 3 times to get 27? And that's the question of not the square root anymore, but the third root or the cube root. Well, 27 is 3 times 3 times 3. I have to multiply 3 times itself 3 times. So the cube root, the third root of 27 is, also 3. We can use any, this is the index number out here. We can take any root we want. If I want, say, the fifth root of 32, I'm asking the question, what number can I multiply times itself 5 times to get 32? Well, 2 times 2 times 2 times 2 times 2 is 32. So the fifth root of 32, what number did I have to multiply 5 times to get 32? Is 2. The thing about roots other than the square root is they get pretty big pretty fast, and we don't necessarily know just by looking. For example, what if I want to know what's the cube root or the third root of 729? Fortunately, the calculator will do this, your scientific calculator. Above the exponent key, you have a little root key with an X up there for you to put in your own roots. So I'm going to use that. Not quite like that. No. On this particular, different calculators work different ways. You have to negotiate with your calculator sometimes to see what it wants you to do. I'm going to tell it I want the cube root first, and then I'm going to hit that key, and 729 is my number. When I hit enter, I get 9. Because if I multiply 9 times itself 3 times, I get 729. So the third root, the cube root of 729, is 9. Of course, we don't always get whole numbers. Suppose I want to know the fourth root of 50. Well, I know 2 times 2 times 2 times 2 is 16. And 3 times 3 times 3 times 3 is 81. There are no whole numbers in between 2 and 3, so this is not going to be a whole number. Let's find out what it is. I'm going to tell it I want the fourth root. Second function, there's my root. The number I care about is 50. And there we go. I don't want all those decimal places. This is an irrational number. It has an infinite number of decimal places. So I'm going to round to 4 decimal places. I'm going to write 2.659. There's the fourth place. The next number is 4, so I'm not going to round up. I'm going to leave that a 1. The fourth root of 50 is 2.6591.